Hi there, how are you doing? Well, we're 5 questions down and 5 to go. And as in part 1, I aim to do each question by hand and then check it with a calculator. So let's dive in. Question number 6. A drug is prescribed as 0.345 grams daily to be given in 3 equally divided doses. State in milligrams the amount of drug needed for each individual dose. Now the thing I want to draw your attention to is this word divided. This is going to be another 2-step question where one of the steps will be divide, and we're going to be dividing by the 3. In addition, you'll notice a mismatch between the units that they've given us in the question, grams, and the units that they want us to state the answer in, milligrams. So let's list those 2 steps that we will need to do. And again, it will not matter which order we do these 2 steps. So step A will be dividing by 3, and step B will be converting grams to milligrams. Now, because we've got an awkward number on that initial value, 0.345, I'm going to do the conversion first, and hopefully my active conversion will make the number I subsequently divide by a little easier to deal with. So I want to convert 0.345 grams to milligrams. Well, let's remind ourselves how to convert. I like to use this visualization with the staircase, and grams to milligrams, well, I'm going downstairs, so I need to move that decimal 3 places to the right, because that's the same as multiplying by 1000. So 1, 2, 3 places to the right. I hope you can see that that number therefore becomes 345 milligrams. So 345 milligrams is given to that patient over the course of a day. And so our final step, what I was calling step A, has to be divide that number by 3. So I'll simply do 3 into 345. Well, 3 into 3 is 1. 3 into 4 is also 1, but with 1 remaining. The remainder always goes below the line. And 3 into 15 is 5. So our final answer, the amount of drug needed for each individual dose, is 115 milligrams. And like I've said several times before, it is very important that you include the units in your answer. Okay, let's check that with a calculator. Turn it on, clear the memory. Well, I did step B first. I converted grams to milligrams, so I had 0.345, and I converted to milligrams by multiplying by 1000 times 1000. Sure enough, that equals 345 milligrams, and then I divided that value by 3, and that sure enough gives us 115 milligrams. And just to check that the order really didn't matter, if I started with the 0.345 grams and divided by 3 first, and then multiply by 1000, I'd come out with the same answer, 115 milligrams. Good stuff. Let's go on to question 7. A patient is prescribed 3.4 milligrams of an elixir. The elixir is dispensed as 1.7 milligrams in 2.5 milliliters. How many milliliters will you need to administer? So there's the units of my final answer, and this question is a classic liquid dose, and for that we use a formula which we've seen earlier on, something like what you want over what you've got times what it's in. But I'd prefer to use this perhaps slightly more intuitive patient over stock times volume. They amount to the same thing, because what you want means what you want to give the patient, what you've got means what have you got in stock, and what it's in means what volume is it in. So let's use that formula to unpack the question. Well, what I want to give the patient is 3.4 milligrams. What have I got in stock? Well, the stock weight is 1.7 milligrams. And what is it in? Well, the volume it's in is 2.5 milliliters. And like I mentioned before, Before proceeding with liquid dose or tablet dose questions, you always check the units in the fraction to see if they are the same. In this case they are the same and we can now proceed directly. If they were not the same, we'd have to convert one of them to make them the same. So mathematically we now need to do 3.4 over 1.7 times 2.5. It looks tricky because that fraction includes decimals, but like before I'm going to do the opposite of simplifying. I'm going to multiply top and bottom by 10, which has the effect of moving that decimal point outside of the number. So I end up with 34 over 17 times 2.5. So we have 34 over 17 times 2.5. On first glance, that fraction does not look like it simplifies, but in actual fact it does, because 34 is just 2 lots of 17. So it in fact becomes 2 over 1 times 2.5. And 2 over 1 is just 2. So if I want to, I can even just ignore that over 1 part. Now 2 lots of 2.5 is just equal to 5. So my answer is 5 millilitres, not forgetting my units. Let's check that with the calculator. Clear the memory. Now we don't need to do all the conversion and multiplying by hand. Once we have unpacked the question using the formula and we saw the units were indeed the same, we can now just input our formula directly into the calculator. We had 3.4 divided by 1.7 times 2.5, and sure enough the answer equals 5 millilitres. Excellent. Okay, on to question 8. Use the table below to calculate a patient's 24-hour fluid balance. Well, there's the table with the values already put in. The total input is 1,989 millilitres and the total output is 2,015 millilitres. In your answer, indicate both the net balance in millilitres and whether your answer is positive or negative. Now we have two numbers and it's a straightforward subtraction, but we have to be careful which value are we subtracting from which. Well, the formula is input minus output, so we have to do 1989 take away 2015. Now I'm going to do this with a calculator first of all this time. Clear the memory. 1989 is the input, take away 2015, the output. And the answer, look at that negative sign, is negative 26. So it equals negative, I'm going to use VE because that's quite a common convention, negative 26 millilitres. I'll write my answer into the answer box, negative 26 millilitres. And now I'm going to check by hand. I've already done the calculator part. Now it turns out that the column method of subtraction can be quite tricky when the answer is negative, because logic would tell us to work it out as 1989 take away 2015. That would seem sensible, but look what happens when we try and do that. You see, 9 take away 5 is 4, and we can see that already we have a problem. 8 take away 1 is 7, 9 take away 0 is 9, and 1 take away 2 is minus 1. That is clearly not the answer we got from the calculator. This is the wrong way of doing it. The important thing when doing fluid balance is to look at your calculation and decide, because you can see clearly whether or not your answer will be negative, and get your sign written in first. So here we could have seen that it was going to be negative, and then regardless of the order of the numbers you must put the larger number on top. So I'm going to put 2015 take away 1989. We already know the answer is negative, so the minus sign has already been taken care of. Now I can say 5 take away 9 doesn't go, so I borrow 1 from there, and the 1 becomes attached to the 5 to become 15. 15 take away 9 is 6, which is looking a little bit more sensible. 0 take away 8 doesn't go. Go next door to borrow, but I can't, so I will borrow from the 2. 2 becomes 1, and the 0 momentarily becomes 10, but then when I borrow from that to 10, it becomes 9, and hopefully you can see through my handwriting, I'm left with a 10. 10 take away 8 is 2, 9 take 9 is 0, 1 take 1 is 0, and when I tidy up, my answer is indeed 26. But importantly, I had already decided on this negative sign, so the negative must go in as well. You can see that for the fluid balance question, it is a straightforward subtraction, and you will do big number take away the small number, but you have to keep a close eye, and this is where the table that they have given you really helps. The formula is always input minus output, and you should be able to see at a glance whether your final answer is positive or negative. Now for answers that are positive, the calculator will not give you a sign, it just won't have a sign. So answers that are positive, you still must put a sign in, and in that case you'd put a plus or a plus VE. So just bear that in mind. For this question and this question alone, there are 3 items that you must put in your answer. There's the sign, there's the value, there's the units. And this is what makes this particular question unique amongst all the questions. Okay, 2 to go. On to question 9. A patient who weighs 110 kilograms is put on a weight loss diet by doctors, and 3 months later the patient weighs 104.5 kilograms. What is their percentage weight loss over the 3-month period? Let me share with you the formula that I think is going to be most effective here. We'll work out the weight loss, and then we will put weight loss over original weight and multiply by 100. In other words, we will express the weight loss as a proportion of original weight, and then to turn that proportion, that fraction, into a percentage, we simply multiply by 100. Okay, let's do this. Well, clearly I'll have to work out the weight loss. So the patient starts off at 110 kilograms and 3 months later weighs 104.5 kilograms. Notice my alignment here. Now the bottom number has a decimal, the top one doesn't, so I'm just going to add a 0.0 on the top one. Whenever you have decimals in a subtraction or an addition, your decimal points must match up. So I can put the decimal point there in my answer line. 0 take 5 doesn't go. I have to borrow all the way from this 1 to leave 0, and that momentarily means I have a 10 there, which I can then borrow 1 from to leave 9, and finally I have a 1 where I need it on my first 0. So 10 take away 5 is 5, 9 take away 4 is also 5, and 0 take 0 is 0, and 1 take 1 is 0. So the weight loss is 5.5 kilograms. I now have all the information I need to put into my formula. 5.5 over 110 times 100. Back in year 1 we saw fractions times fractions, so rather than worrying about multiplying too many values by that 100, I'm just going to put it over 1 to make it look like a fraction times fraction. I have not changed the value of that number 100. Now I have an awkward looking fraction there on the left, 5.5 over 110, so I'm going to do the trick I showed you earlier of multiplying top and bottom by 10. Move the decimal point 1 place to the right. In other words, I have 55 over 1100, you saw the 0 that went into that empty loop, times 100 over 1. Now it all looks a bit tricky, but we can just hold our nerve here, because with the first fraction 55 and 1100 we can see that 5 goes into both. Now 5 goes into 55 11 times, and 5 goes into 1100. Well, that I can't do in my head, so I'll just work it out here. 5 into 1100. 5 into 1 doesn't go. 5 into 11 is 2 remainder 1. 5 into 10 is 2. 5 into 0 is 0. So that 55 over 1100 becomes 11 over 220. And as luck would have it, 11 goes into both top and bottom. So dividing the top by 11 is just 1, and dividing the bottom number by 11 is 20. So I've simplified right down my 5.5 over 110 times 100 into 1 over 20 times 100. Well, top times top, bottom times bottom. 1 times 100 is 100. 20 times 1 is just 20. I can simplify that down because they both end in a 0. I can divide by 10. That becomes 10 over 2. And I can halve it to give the answer 5 over 1, otherwise known as 5. So my final answer is equal to 5%. That would have been tricky to have guessed from the outset that we'll get such an easy looking answer. This is definitely one question that is far easier with the calculator. So I'll clear my memory. My weight loss, let's just check I got that correct. 110 take away 104.5. That does indeed equal 5.5. So I then had weight loss over original weight, so divide by 110 and then multiply by 100 over 1. Sure enough, the answer is just 5%. You could use this method also if the question was about a patient gaining weight. Your formula would then, instead of saying weight loss over original weight, would say weight gain over original weight. And again, you'd simply times it by 100, or in our case, by 100 over 1 to work out the proportion as a percentage. Okay, almost done. On to the last question. Question 10. The doctor prescribes 3 grams of medication. Stock dose of the medication is 0.75 grams. How many tablets should you give? So this is a tablet dose question, and therefore I need to know what the tablet dose formula is. And it will look fairly familiar. It is the first part of the liquid dose formula. It's what you want over what you've got. Or as I prefer to think of it, what you want to give the patient over what you've got in stock. So I can use either of those versions of the formula. I will use the version on the right hand side. Well, I want to give the patient 3 grams. And in stock I've got 0.75 grams. Now the units are the same, top and bottom, so I can proceed. Calculator wise this will be easy. To do it by hand looks a little tricky. It looks like a very nasty looking question. However, remember the trick we did before to get rid of unwanted decimals in a fraction. I'll just write it out again, 3 over 0.75. Now there's only one number with a decimal, it's that bottom number. I want to move that decimal 2 places to the right, and that would get rid of it. So what I must do to make the value of the fraction the same is also move this top number likewise 2 places to the right. You can see that that would become 300 over 75. So I'm now left with 300 over 75, which now will simplify. 5 will go into both. Not sure about this, so I'll just work it out pen and paper. 5 into 300, 5 into 3 doesn't go, into 30 is 6, and into 0 is 0. And likewise 5 into 75, 5 into 7 is 1, remainder 2, and 5 into 25 is 5. So my 300 over 75 becomes 60 over 15. Well, that also simplifies by dividing by 5. 5 goes into 60 12 times, and into 15 3 times, and finally we can see that 3 goes into both. My answer is 4 over 1. In other words, my answer will be 4 tablets. And here that word tablets is effectively acting as if it was my unit. It's still important to give every numerical value a context label. Whether we disagree that the word tablet is a unit or not is besides the point. we are not just giving the patient 4, we are giving the patient, to be precise, 4 tablets. Let's check that with the calculator. Clear the memory. What you want over what you've got, and because both units were grams, I can do it in one step. 3 divided by 0.75. And the answer is indeed 4 tablets. Look how easy it was on the calculator. We had to use all sorts of mathematical trickery in dealing with such an awkward looking fraction. The strength of the calculator is definitely apparent here, but I will still maintain that a deeper understanding of how to do it by hand allows you to get a better feel for what the answers should look like, and that would guide you against putting values into the calculator wrong and simply not spotting that. And that, boys and girls, brings us to the end, to the second half of the paper, and so between the two videos we've now covered one realistic example of the entire second year adult branch numeracy paper. Thanks for watching.